Wonderful day it is. Today we're going to do a bit of practice, and our practice is going to be based on the A level, question beginning. Okay, so we're going to do some practice on A level questions. Okay, so A level practice. We're not going to take all my time. So our work is going to be based on A level practice. Okay. Now let's see some few questions that we've been given to sort them out. So the first question says, question one says, let me write it down. Say find the largest, find the largest possible domain. Find the largest possible domain of function f of x equals to natural log of 8 minus 3x. Okay, so such a question where when we meet such a question, say find the largest possible domain of a function f of x equals natural log of 8 minus 3. If we look at this question, you see you have to take the log of positive integer. So note, first of all, we have to take log of positive integer. So note, so this one, we can take the log of positive integer. Okay, so the question itself says the function f of x is given as natural log of 8 minus 3x. Okay, we should find the possible domain of the function. So for f of x being equals to natural log of 8 minus 3x, as we are taking the positive integer of the log, so this implies that the 8 minus 3x should be greater than 0. If that is the case, then we can say 8 minus 3x. So this one will be this greater than 3x. Okay, meaning that 3x is less than 8. Okay, so that when we divide both sides by that, we are going to get x to be less than 8 over 3. Okay, so 8 over 3, this is the domain of the given function. Because 8 minus 3x. Okay, so what we do is just do manipulation of the equation, and that our possible domain, this will be equals to 8 over. So this is the possible domain. Okay, so 8 is greater than 3x, meaning 3x is less than 8. So that will be the function. Okay, let's see the other one given as well. Question 2 says what is the largest possible domain? What is the largest possible domain yeah, largest possible domain of the function g of x implies 1 over x minus 3 plus square root of x plus 2. Alright, so what is the largest possible domain of such a function? So, when we get a question of this sort, we have to look at it very carefully. You've seen that we have 1 over x minus 3, okay, and the square root of x plus 2. When we look at it very carefully, you will see that x minus 3, if x is equal to 3, then the whole expression will be 1 over 0, and that will make the function not easily to break it down. So there will be a division of by 0 when x is equal to 3. So that is one condition. Okay. Also, the other parts, this one, if x is equal to minus 2, okay, it means that function will give us a problem. So there will be the square root of a negative number when x plus 2 is also less than 0. Okay, so let's look at it. These are the possible ways of being able to ascertain the domain of such function. So let's see. So our solution will be okay. So we have g of x given as 1 over x minus 3 plus square root of x plus 2. So when you're supposed to find a domain. So the first case, in the case 1, if x minus 3 is not, it shouldn't be equal to 0. Okay, the reason being that if we have x minus 3, okay, supposed to be equal to 0, this will be, yeah, there will be a division. There will be a division by 0 when x minus 3, I'm clean here, when x minus 3 is equals to 0. So when x minus 3 is equal to 0. Okay, so when x minus 3 is equal to 0. So therefore, x minus 3 shouldn't be equal to 0. And if that is the case, then x shouldn't be equal to 3. So this is a possible domain. The next one, let's look at it. Let's look at case 2. Case 2. Okay, if x plus 2, okay, should be greater than 0. Should be greater or equal to 0. Because if it's greater than 0, then there will be the square root, Okay, so if let's see the condition for this one. The condition for this one is there will be the square root of negative number when x, see, then when x plus 2 is less than 0. Okay, so that is the reason why we say that x plus 2 should be greater or equal to 0. Okay, so that x is greater or equal to negative 2. Because if x is greater than negative 2, there will be a negative square root. If x is equal to negative 2, and we substitute that into the expression here, there will be a square root of 0. So therefore, the possible domain is, as we can see, is given as x greater or equals to negative 2 and x not equals to 3. So the domain will be negative 3, 2, okay, and 2 to infinity. This will be the domain of a such function. Let's look at the third question. Our third question says, given that function f of x is given as 3x plus 1 and g of x is given as 1x over x squared plus 25. Okay, the question says solve the equation g f of x is equal to 0. Okay, so this is the question number 3. We have been given a function 3x plus 1 and g of x is equals to x over x squared plus 25. Solve the equation such that g f of x is equal to 0. So our solution to such a question, let's tackle this question. So we have been given a function says f of x should be equal to 0 is the condition that we have been given. Okay, but we know the specific functions. Our f of x is given as 3x plus 1. Okay, and g of x is given as x over x squared plus 5. Okay, so since this is the demarcated equation, the equation, okay, that they want us to handle, so we can say that f such that f of g such that f of x mean is g is standing as f of x is coming into the equation. So if that is the case, then we have to say that to be able to get the function f of g of x to be equal to 0, the g of x is x plus x over x squared plus 5, and f of x is 3x plus 1. So what we are going to do is to substitute f of x into g. So f of x into g. So that was f of 3x plus 1 into g will be equals to, wherever we see x, that will be 3x plus 1. So this will be 3x plus 1 all over 3x plus 1 squared plus 5. So this is the definition of g f of x. So that is what the question says. It says g stands as f enters. So g f of x is given as you can see. So with this, it's interesting to understand that even when we expand, our solution will be straightforward. So this implies that this whole equation, 3x plus 1 over 3x plus 1 squared plus 5 is equal to 0. Right? So what do we do? Because this is the denominator, even when we expand it, what we are going to get is 3x plus 1 all over 6x squared, no, 9x squared, and we'll expand that. We are going to get 9x squared plus 6x, okay, plus 1. Plus 5 is equal to 0. Why am I saying that? Because we know when we multiply 3x by plus 1 by itself, we are going to get 9x squared plus 3x plus 3x plus 1. Okay, so that's what we're going to get, the 9x squared. Okay, 9x squared multiplied by that, 3x, write it down. And this one will multiply by that and that. So that is the equation plus our 5. That will make our equation be 9x squared plus 6x plus 6. Yeah? So the whole equation is going to be 3x plus 1 all over this denominator plus 6. Okay, so the plus 6. So what can we do? Plus 6. Is equals to 0. So when we cross multiple, if that is the case, we're going to multiply both sides of the equation by that. So our equation, this one will be 3x plus 1 equals to 0. So 3x is equals to negative 1. Therefore, x is equals to negative 1 over 3. It's the solution. So that is a given that solve the equation that. So that's what we get. Right. So let's look at the last question. Question 4. Our question 4. that says the function f is defined by f such that this is mapped to s cubed is defined the expression for g of x in terms of x in each case. Okay, so the cases are f of g into bracket x is equal to 2x plus 3 and gf of f into bracket x is equal to 3x plus 4. Alright, so this can be a very interesting question to deal with. So we have an f of x that maps to s cubed. It's a find expression for g of x in terms of x in each. So if that is the case, let's see. So solution 1. So if we tackle the first case 1, the question says f of g of x is giving us 2x plus 3. So this implies that f g of x is equal to 2x plus 3. So now we know f function f, so the g is given to, since we know f of x initially, it to be equals s cubed. So we find a g of x from each. So the function f itself has been given, so we are substituting in the g. So in this case, if that is the case, we're looking for g of x. The function of x has been given as s cubed, and g of x is going in. So how do we find our g of x? Okay, because see, we should find g of x in each case. So f of x has been given as s cubed. Okay, then we have g of x. That's what we're looking for. So g of x of that will be equals to the s cubed to 2x plus 1. Okay, 2f5 plus 1. So let's see what clean. So g of x, f of x, okay, let's write it well. So f of x has been given to us like that, and g of x has been also been given. So now we're looking for g of x. So f of x is given as s cubed multiplying g of x as the function is equal to 2x plus 3. Okay, so to find the g of x, we are going to get 2x plus 3 all over x cubed. So that is g of x. Okay, let's look at case 2, where the question says g of x, g of f of x is equals to 3x plus 4. X plus 4, given f of x, meaning the g is standing there and f is entering. Okay, b equals to 3x plus 4. We don't know the g. We don't know the g of x. The f, but we know f of x. So g of x multiplying by f of x, which is x cubed, is given 3x plus 4. Okay. The same way, the g is standing and f is entering. So our g is what we are trying to find. So the g, function g, will be g of x will be equals to 3x plus 4 all over x cubed. So these are the solutions we are able to come out with. The function f of x is defined by that. Find expression for g of x in terms of x in each case. So since we know f of x, all what we have to do is to put into the composite function and work it out. And as we work it out, that's what we get. And this is what we get for the other one. It's been beautiful today. And let's tackle things once more. These are the questions we have for tonight. Anyway, please don't forget to like, share, and subscribe to my channel. Many thanks in advance. See you again.